horizontal cabling, yes, physical separation between communication cables such as UTP and coaxial and power cables is required as per National Electrical Code, or NEC, Article 800.52(1). See in exception No. 1. The barrier mentioned in exception No. 1 is a separate raceway compartment or other type of physical separation between the power and communication cables. Regarding the work area for a personal computer or modem, NEC Article 800.52 does not specifically address this, but it is generally not required to ensure physical separation between communication cables and power cables in the work area for a personal computer or modem. However, some organizations may have additional requirements for this purpose. NEC Article 800.52(2), Exception No. 1 and Exception No. 2 provide methods for allowing power and communication cables to be in the same raceway or enclosure, but these exceptions may not be applicable to all situations. In general, it is not required to use a continuous and firmly fixed non-conductor between the power and communication cables, but it is recommended as a best practice to follow the NEC guidelines and maintain physical separation as much as possible. Yes, physical separation between ground wire and communication cables is required both inside and outside of enclosures during the installation of new hardware. This is to prevent ground loops and other interference issues. NEC Article 852 defines aspects such as power-limited circuits in compliance with Article 725. A power-limited circuit in compliance with Article 725 is a circuit that has a maximum voltage of 150 volts alternating current or 300 volts direct current, and a maximum power rating of 100 volt amps. These circuits are typically used for low-power devices such as doorbells, intercoms, and thermostats. Regarding Type AC and Type UF cables, Type AC cable is a non-metallic sheath cable that is suitable for use in dry or damp locations and is rated for up to 1000 volts. Type UF cable is an underground feeder cable that is suitable for use in direct burial and is rated for up to 600 volts. To elaborate on the requirements for physical separation between communication and power cables, it is important to understand the reasons behind these regulations. Firstly, electromagnetic interference, or EMI, is a significant concern. Power cables can emit electromagnetic fields that can interfere with the signals carried by communication cables. This interference can lead to data corruption, reduced network performance, and even system malfunctions. By maintaining physical separation, the effects of EMI can be minimized, ensuring the integrity of communication signals. Secondly, safety is another crucial factor. In the event of a fault in the power cable, such as a short circuit, the high voltage and current can potentially damage nearby communication cables and pose a safety hazard to personnel. Physical separation helps to reduce the risk of electrical shock and fire. Thirdly, regulatory compliance is essential for ensuring safety and reliability in electrical installations. The NEC provides specific guidelines for cable separation to minimize the risks associated with mixed cabling systems. Compliance with these regulations is not only a legal requirement, but also a best practice for ensuring the safe and efficient operation of electrical and communication systems. Now let's delve deeper into the specifics of horizontal cabling. In horizontal cabling, which refers to the cabling that runs from the telecommunications room or equipment closet to individual work areas or outlets, the NEC requires physical separation between communication and power cables. This requirement is outlined in Article 800.52(1) C, which states that communication conductors shall not be placed in any raceway, compartment, outlet box, junction box, or similar fitting with conductors of electric light, power, Class 1, non-power limited fire alarm, and medium power network powered broadband communications circuits. However, there is an exception to this rule, as mentioned in Exception No. 1, which allows for the placement of communication and power cables in the same enclosure if they are separated by a barrier. This barrier can be a physical partition, such as a metal or plastic divider that effectively isolates the power and communication cables from each other. The purpose of this barrier is to prevent any potential contact between the cables and to minimize the risk of EMI and electrical shock. Moving on to the work area, the NEC does not explicitly address the physical separation of communication and power cables in the work area for a personal computer or modem. This means that, in general, it is not required to maintain strict physical separation between these cables in the immediate vicinity of the workstation. However, it is still recommended to follow best practices and to minimize the proximity of power and communication cables whenever possible. One reason for this is to reduce the potential for EMI, even though the risks may be lower in the work area compared to horizontal cabling. Another reason is to prevent accidental damage to the cables, such as from being pinched or crushed, which could lead to safety hazards or communication disruptions. While the NEC does not mandate physical separation in the work area, it does provide some guidance on how to manage power and communication cables in shared spaces. Article 800.52 Exception No. 1 and Exception No. 2 offer methods for allowing power and communication cables to be in the same raceway or enclosure, but these exceptions may not be applicable to all situations. Exception No. 1 states that where all of the conductors of the electric light power, Class 1, non-power limited fire alarm, and medium power network powered broadband communications circuits are in a raceway or in metal sheathed or metal clad cables, the communication cables can be installed in the same raceway or enclosure without a barrier. This exception is based on the assumption that the metal raceway or cable provides adequate shielding and protection against EMI and electrical hazards. Exception No. 2 states that where the communications wires and cables are permanently separated from all of the conductors of electric light, power, Class 1, non-power limited fire alarm, and medium power network powered broadband communications circuits by a continuous and firmly fixed non-conductor, such as porcelain tubes or flexible tubing, in addition to the insulation on the wire, the communication cables can be installed in the same raceway or enclosure without a barrier. This exception allows for the use of non-conductive materials to provide physical separation between the cables as long as the materials are durable and securely installed. In practice, it is often easier and more cost-effective to simply maintain physical separation between power and communication cables in the work area, rather than trying to comply with the exceptions outlined in the NEC. This can be achieved by using separate cable trays or pathways, or by simply routing the cables along different walls or surfaces. Now let's discuss the importance of physical separation between ground wires and communication cables. Ground wires, also known as equipment grounding conductors, are used to provide a low impedance path for fault current to return to the source in the event of an electrical fault. These wires are typically connected to the metal enclosures of electrical equipment, such as power supplies and junction boxes, to ensure that the enclosures are at ground potential. Communication cables, on the other hand, carry low voltage signals that are susceptible to interference from electrical noise. When ground wires and communication cables are run in close proximity to each other, there is a risk of ground loops and other interference issues. A ground loop occurs when there are multiple ground paths between two or more pieces of equipment. This can create circulating current in the ground wires, which can induce noise into the communication cables. The noise can manifest as hum, buzz, or other unwanted signals that can degrade the performance of the communication system. To prevent ground loops and other interference issues, it is essential to maintain physical separation between ground wires and communication cables. This can be achieved by routing the cables along different pathways, using shielded communication cables, and ensuring that all equipment is properly grounded. It is also important to avoid creating multiple ground paths by connecting equipment to different electrical circuits. In some cases, it may be necessary to use isolation transformers or other devices to break ground loops and to isolate sensitive communication equipment from electrical noise. Now let's move on to the definitions provided in NEC Article 852, which relate to power-limited circuits and cable types. A power-limited circuit, as defined in Article 725, is a circuit that has a maximum voltage of 150 volts alternating current or 300 volts direct current, and a maximum power rating of 100 volt amps. These circuits are typically used for low-power devices such as doorbells, intercoms, and thermostats. Power-limited circuits are designed to limit the amount of energy that can be delivered to a load, which reduces the risk of electrical shock and fire. These circuits are often used in applications where safety is a primary concern, such as in healthcare facilities and schools. Type AC cable, also known as armored cable or BX cable, is a non-metallic sheathed cable that is suitable for use in dry or damp locations and is rated for up to 1000 volts. Type AC cable consists of insulated conductors wrapped in a flexible metal armor, which provides physical protection and shielding against EMI. Type AC cable is commonly used in residential and commercial wiring for branch circuits, feeders, and appliances. Type UF cable, also known as underground feeder cable, is a type of cable that is specifically designed for direct burial in the ground. It is suitable for use in wet or damp locations and is rated for up to 600 volts. Type UF cable consists of insulated conductors encased in a solid, water-resistant thermoplastic jacket. This jacket provides protection against moisture, chemicals, and physical damage, making it suitable for underground installations. Type UF cable is commonly used for supplying power to outdoor lighting, pumps, and other equipment. In summary, understanding the NEC requirements for physical separation between communication and power cables is crucial for ensuring safety, reliability, and performance in electrical and communication systems. By following the guidelines outlined in the NEC and by implementing best practices for cable management, you can minimize the risks associated with EMI, electrical shock, and fire, and ensure the safe and efficient operation of your systems.